All right, the last lesson of this chapter, chapter 6, lesson 8. This is solving two-step inequalities, and that's exactly your learning target, is I know how to solve two-step inequalities. Okay, we've taken a look at pretty much the basic rules of inequalities, how to solve inequalities by adding, subtracting, multiplying and dividing positive and negative numbers. And today we're going to focus on two-step inequalities. So we're going to bring all that we learned in those one-step inequalities and apply them to this two-step inequality problems. So your key concept here is to solve two-step inequalities, you simply have to solve for the variable by undoing in reverse PEMDAS order. Okay, so let's go ahead and just get right on it and look at example 1. Example 1 asks us to solve 6 minus 3x is less than or equal to 9. Check your solution, then graph the solution on the number line. So again, we're trying to figure out what values of x, if we plug in numbers for x, what values of x would make this inequality true. So we have to undo this two-step inequality by using reverse PEMDAS order. That means we have to start with adding and subtracting. And so if there's anything adding or subtracting here, that's what we want to do first. And because it's 6 minus 3x, we got to get rid of that 6 first. And remember, this is a positive 6. Even though this is minus 3x, this is a positive 6. So we have to subtract by 6 on both sides. When we do that, we're left with a negative 3x is less than or equal to 3. Okay, at this point now, negative 3 is being multiplied by x. So all we have to do is just get rid of that negative 3 there, and they're being multiplied. So the opposite of multiplication is division. So we're going to divide by a negative 3 on both sides, and we end up getting x is less than, we divided by a negative number, so we have to switch the signs, is greater than or equal to a negative 1, because 3 divided by negative 3 is negative 1. Okay. Alright, so I went ahead and just fixed that up, cleaned it up a little bit so it looks a little bit nicer. Okay, so now what we need to do is we need to check our work. And we do that by plugging in a number that this inequality says would be true. So if x is greater than or equal to negative 1, we have to choose a number where this is true. So like for example, 0. 0 is greater than negative 1. So let's plug that into our initial inequality here. So we have 6 minus 3 times 0, because I'm plugging in the 0 for x, is less than or equal to 9. And if we solve here, now when we're solving, we're using the PEMDAS order just like we normally would. We get 6 minus 3 times 0 is just 0. So 6 minus 0 is less than or equal to 9. And 6 minus 0 is just 6. And 6 is less than 9. So that checks out. That works out. And so our last thing that we need to do then is to graph this on a number line. So I'm going to draw my number line here. And our important point to realize is negative 1. So I'm going to start with 0 in the middle. 1, 2, we'll go out to 3. And then negative 1, negative 2, negative 3. Alright, it says x is greater than or equal to negative 1. So we have to put that dot right there at negative 1. And it's going to be filled in because this includes negative 1. It's equal to negative 1 as well, so we have to include it in that. And x is greater than that. Well, negative 2 is not greater than negative 1. 0 is, so that means that we're going in this direction to the right. And that's how we do it. Okay, let's do another example. Example 2 says, solve h divided by 4 plus 3 is greater than 7. Check your solution, then graph the solution on the number line. So we have to get rid of this. We're working in reverse PEMDAS order, right? And so we have to add or subtract first, and we want to get h by itself. That means we have to subtract out the 3 first, because if we do that, that will get h divided by 4 alone. And we're working in reverse PEMDAS order. 7 minus 3 is 4. Okay, now we got to get rid of this 4, and it's h divided by 4. So if we multiply by 4 on both sides. We're going to get these to cancel out, and we'll just be left with h is greater than 16, because 4 times 4 is 16. H is greater than 16. So let's plug in a number that would work for this. If h is greater than 16, we could plug in, say, 20 for h. So I'm going to go ahead and plug in 20 here for h. So it'll be 20 divided by 4 plus 3 is greater than 7. And 20 divided by 4 is just 5 plus 3 is greater than 7. And 5 plus 3 is 8, which is greater than 7. So that checks out. We're all good there. Now the final thing we have to do is just graph this on a number line. Our key point again is 16. So we need to start here with 16. We'll go to 15 and 14. We'll go up to 17, 18. This is going to be an open dot at 16 because it does not include, there's no equal to sign, so it does not include the number 16, but we do know that h is greater than 16, and 17 and 18 over on this side are greater than 16. And we've shaded in, and that is all we need to do. Perfect. Peace.